So for this week's module, we're going to be going over a little bit more with data management, specifically looking at pivoting the data as well as some more mutations with the data. So we're going to look at altering factors in data sets with those mutations, and that can be especially helpful when summarizing your data for use in a figure later on, or if you're making some sort of table. First, we're going to look at pivoting the data, which is helpful for making summaries of data sets or doing analyses on because we need to make separate factors into different columns or combine all the factors into singular columns depending on our visualizations. So first we're going to load the tidyverse package and the fish data set we've been working with, which again, the fish data set is from the Upper Mississippi River Restoration Program's long-term resource monitoring element, and it's community data from 6 sites on the Mississippi River, and this is a subset from 2018. So first we're going to talk about pivoting wider or longer. So if you have data where there are multiple factor entries in the same column, like you have a column that's species, and then you have all the species within that column, and you want to separate each factor into its own column. So then you would take those species within that column and put them in their own column. So we have maybe like a catfish column, a bluegill column, white-tailed deer column, etc. You can do that with pivot wider. Pivot underscore wider is the easiest way to do that. If you want to do the opposite, where you have those individual species columns, so the catfish, bluegill, white-tailed deer, and you want to make them all into one singular or two singular columns, one that has the species code and one that has the value that was in those cells, that's pivot longer. So this is like making pivot tables in Excel somewhat. You are just changing the shape of your data so you can do different analyses on it. So if we were to make a summary table of the fish data set, we're going over this code. We are just summarizing the sample size by each species and field station or sampling site. So we take our fish data set and we're using the pipe to group by species and F station, which are species and field station. And then we're using summarize. And here we specify dplyr if we have other packages that also have a summarize function. We run into issues with this a lot. So if you need to use specifically the dplyr summarize, specify the package name, colon, colon, and then the function name. And here we're just summarizing sample size. So we're saying n sample size, whatever you want to call it, equals n open parentheses. So it's just doing a count. And we're making this as a tibble, which is something that's more easily manipulated in R just to make it easier. So we took all of our community data and now we have field station number, species, code, and the sample size for each. If we wanted to make this like a table in a manuscript or report or something, like this information might be really helpful to know where the largest sample size is coming from, which species have the largest sample size, etc. But having this in a long format does not make it easily comparable. So we've got 36 rows here, and we got to like keep scrolling down in R at least to look at everything. But if we had these data more spread out by either field station in the rows or columns or species in the rows or columns, this would make it a lot more comparable and it would fit in one frame. So that's what we're going to do with pivot wider. We're going to take this table and we're going to make it wide format so it's more easily comparable. So this data set's in the long format. So we see how the grouping variables, species, and field station are listed in the rows. So long format, which is very helpful also for different analyses, for different visualizations, but for a table, we want it in wide format. So let's look at structure of our data again, long format here. So we're going to pivot wider one of the columns of data into several columns, which makes it which may make certain functions doable, like if you want to do a certain analysis or a certain visualization, or for our purposes, it's going to make a table more visually appealing and easier to compare those data. So what we're going to do is put the data set into what's called a wide format, where each field station is now a column. So we're going to take this field station column and we're going to change it so each field station number, which is 1 through 6, has its own column. So what this looks like is this is in the tidyr package, which is loaded with the tidyverse packages. But just so you know which one it is specifically, taking our fish2 data set, which is the column summaries, and we're using this function pivot wider. So ID expand here is an optional argument, and it means that if you have missing data from columns, like you took no temperature data October through December, and you have temperature data the rest of the year, it's going to create those empty rows. It's basically like using the complete function from last data management discussion within the pivot wider function. But what's most important here for pivoting wider is this names from and this values from arguments. So names underscore from, these are where the names of your column are coming from. And because we said we're going to make F station its own column, our names would be from F station. And then our values are from, this is what's going to be put in these cells. So that's labeled N here, capital N. Values are from N. So what this does is it takes that F station column and breaks it up into 6 different columns, one for each of the factors in F station, and our sample size fills in the cell values. So now we have species, and then we have 1, 2, 3, 4, 5, 6, and the cells of sample size for each of those field stations and species combinations. And this is much easier to see for a table. It's much easier to compare these values than looking in that wide format. So this is something that's really appropriate for publications or reports, is just make it as simple as possible, easily to compare, as small as possible too. So we've got a compact, much better here than that long format for our purposes. I want to note here that the station IDs are numbers, which make sometimes annoying column names. So you can use names prefix like equals S to add S to the start of the station name, like F station equals 1 becomes F station equals S1. So what that might look like then is if we add this to the code, or if you have issues with column names or anything you want to do like that, you can use this names prefix and just put S there. Now let's change it to S1, S2, S3, S4, and you can put really whatever you want here. You could put field station, do whatever you want. Now we have field station 1, field station 2, etc. So that's a different way to alter the names of those columns moving forward too. Right now we're going to remove that from our code and just have it 1, 2, 3, 4, 5, 6. So now we're going to do several other tidyverse functions to change the look of this table. This is what we have. We want to make it more ready for a report or publication. And one of the biggest things here is that we can rename the species and rename these columns. So species, these codes may or may not be intuitive to people. You may not want codes in a table. You just might want the common name or scientific name. And for 1, 2, 3, 4, 5, 6, you probably don't want to just have those numbers there. You probably want to actually have some sort of meaning with them, like what area they were sampled from, because these are field stations. We don't just want to number those field stations. We actually want to give the name of them. And if that isn't in your data already, you can code it with using mutate from our mutate dplyr friendly functions, and also rename for those column names. So we're going to use these dplyr functions to help us rename bits of our table. So we're taking our table that we just made, and we want to rename those columns from 1 through 6 to what sampling reach they were, which to do that, we're using rename, which we learned in the first dplyr module. So it's just the rename function, and it's always new name equals old name. This note here was you can have numbers which make annoying column names, being that you have to put tick marks around them. So otherwise, it's just a 1 and it shows up in my color scheme as green, which is basically just saying that this equals a number of 1, when in fact we need to make sure it's known as a column name. See how it changes to white here with those tick marks? Now it's saying that that's a column name. So if you have numbers or spaces within your new names or old names, you have to put those tick marks around the column names or any factor names as well. So field station 1 here is actually pool 4 of the Mississippi River, so that's what we want to put there. So we have pool space 4 surrounded by tick marks. And we're saying that equals to 1. So we're changing that 1 column. 2 here is pool 8, 3 pool 13, 4 pool 26, etc. So it's just changing those names from 1 through 6 to their respective sampling location. Pool 4 all the way through the open river and Lagrange pool in this system. So then we have different column names. We've got pool 4, pool 8, etc. That was all changed, and that's using the rename function here. Now, what about these factors for the species? Maybe we want scientific name or common name here and not just the 4-letter species code in the species column. We can't use rename because rename is for column names specifically. What we can do is what's called factor recode using the forcats package within the tidyverse. So forcats works with factors specifically. So here, take our data set that we just changed the names from in the columns there, and we're going to use mutate to change these species names. We're also going to use mutate like we have in the past in the dplyr module to create a sum column. So maybe we want sample size of each species individually. So all bullhead minnow, what is their total sample size across those reaches? All bluegill, what's the total sample size? So this first mutate here is what we've done already, where we're saying we're calculating something based on our data. We're saying total equals, and then plus all the names of those columns we just made here. Pool 4, 8, plus pool 13, plus pool 26, plus open river, plus Lagrange pool. And what this does is it gives us a total column. So that's total sample size of bullhead minnow across all 6 study sites, total sample size of bluegill, etc. So that's how we've used mutate before. This way to use mutate, we are changing the factors here. We're changing these 4-letter species codes to the common name. So we say mutate, and we are mutating that species column. We're just going to write over it. So it's the same thing as we've done with mutate already. We're saying a column name, and that is our species column, and that equals a function. This function is factor fct underscore recode, recode. And within this function, we specify the column we are altering, comma. And then you just go down the line. The new name for the factor bullhead minnow equals the old name. Here it must be in quotation marks for both, just so it knows what factors you're looking at. And then just separate each factor by a comma. So bluegill equals BLGL. Channel catfish equals CNCF, etc. So what this does now is we look at our observations too. All right, so we've got the species, now the full common name here. We have the pools here, and we have that total at the end. So we have all of our information we added using fact or mutate twice. So mutate the total sample size and then mutate through factor recode. And you have to use this factor recode if you're changing factors within a column. One thing that is really helpful as well, which you can also do with factor recode if you want, is this factor collapse. So this might be something that's like we're changing something to like a trophic guild, and we want to create a new column based on certain factors. We're going to use what's called factor collapse instead of factor recode. So this code here so far is the same. Specify our data set, the pipe, use mutate, specify which column we want to change. So here we're changing the species column, and we're saying it equals for the function is factor collapse, FCT underscore collapse. And then you specify which column you are changing again. Let's say here we want different trophic guilds. So we want forage fish, omnivore, and invertivore for our guilds specifically. So we have the name of forage fish, and that equals C for concatenate because we were going to have multiple factors in these. It equals bullhead minnow, comma, emerald shiner, comma, gizzard shad. And that's our three species we're changing to be called forage fish. Comma, and we're saying, all right, omnivore then is C, channel catfish, comma, invertivore equals C, bluegill and freshwater trout. So what this does is it collapses those factors into one another. And now we have forage fish, invertivore, omnivore, forage fish, invertivore, forage fish. It doesn't automatically collapse, like adding sample sizes or anything together. If you wanted to do this like factor collapse, I would do it before making the table, because otherwise you're going to have repeat code or repeat lines with the same species here, for example. What you could do if you wanted to just recode this or something, we could change this to, let's say it's trophic yield is our new column name. Instead of rewriting or overwriting species here, we're going to keep that species column and make a new column called trophic yield. So now, if we look at the end, we tacked on that trophic guild column, which has the forage fish, invertivore, omnivore, etc. And we still have our species here. So that's another way you can do this with mutate, is you don't have to overwrite the column you are changing. You can make a new column using this information. So as we can see from the above code chunks, mutate has many roles. We're always adding a new column or overwriting a column that exists. We can create those new data columns, we can rename factors, we can change column names, and there's a lot more we didn't cover, like using case when and a few other examples. The commonality with mutate functions is that we specify the mutate function first, provide a column of data we want to manipulate, and then specify another type of function. Doesn't matter if we're creating a new column, a summary column, or if we're factor recoding or factor collapsing on the same column. We're using mutate to overwrite data or to create new data. And then finally, so that's some of the mutate stuff. Finally, we have our data here, what this looks like. And maybe we want to put it in that pivot wider or pivot longer format again, like how it was more originally. So if we have multiple columns that we want to combine into one column, you can do that with pivot longer. It's the opposite of pivot wider. So this is to just show that the opposite and how to do that. We're taking our observations 2 data set. We've got the species name, we got the pools, the total here. We're saying select, get rid of the total if we want it. We don't have to have that in there. Maybe we just want the different pools only and not the total of them. So we're just saying get rid of that, select minus the total. Pivot longer. This is the opposite of pivot wider where we had names from and values from. Now what we're doing is names to and values to. So it's going to say what names. We want these names. What are we changing their column name to be when they're all put into one column? And we're just going to call that site. So quotation marks site here. The values to all the values within those cells. What are we naming that new column? We're just going to name it N for sample size. We can do whatever we want here. Sample size, N, whatever you want. And then you have to specify which columns you are going from wide to long with. So here, if we want just the sampling reaches, we've got, this is column 2, 3, 4, 5, 6 for the open river, and 7 for the Lagrange pool. So we're taking columns 2 through 7. And what this does then is we've got our species column, our site column, because we told it to name it site, and N for our sample size, because we told it to name it N. So now we've just gone back into that long format where you've got the species, site, and sample size, just like we had before we made it wider, but now we have species common names and the site names instead of the 4-letter codes and the number for site. So that's all for today. For this module was going over some things like pivot wider, pivot longer, as well as some things to use mutate with and altering things to look like a nicer table if you're creating some sort of summary table. So mutating with factor recode and factor collapse.